Here you can see my color-coded 3D printer in the colors of red, green, and blue. This is simply just a modified version of the Adoptabot by Brook Drumm. All I did was separate it into the X, Y, and Z sections and print them in the colors red, green, and blue. The red pieces make up this X-axis. Over here we have the Y-axis in green. And last is the Z-axis in blue. There is a fourth part, and that is the extruder in gray at the front. This is a stepper motor, and pretty much every axis and the extruder has a stepper motor that controls its movement. Here is the X-axis motor, which pulls a belt for the X-axis movement. The Y-axis motor is like the X-axis motor, it also pulls a belt. The Z-axis motor is a little different. It turns a threaded rod that will raise the Z and also the Y-axis arm. And last we have the stepper motor for the extruder, which actually pulls the plastic through that is getting melted and deposited below. By pulling on this manually, I can move the X-axis left and right, I can push the Y-axis forward and back, and I can move the Z-axis if I spin it here. This is actually lowering the Z-axis, although very slowly. With the printer powered on, I'm going to home the X-axis to show you the left and right movement. Here it hits an end stop to find the end of the X-axis movement. Next, homing the Y-axis, you can see it's moving in the forward and back direction, and it again hits an end stop that identifies the end of this movement. Finally, I'll home the Z-axis, where the leveling probe will actually sense the height of the bed and stop when it reaches the bed of the printer. With all three axes homed, this is essentially the starting position where the printer knows its location, and all other movements are based off this home location. The fourth motor is responsible for extruding the plastic, so whenever this motor moves, the plastic is being pushed through this hot end where the plastic softens and comes out as a melted strand below. Whenever the printer is actively building a model, the hot end is moved around by the X, Y, and Z motors so that the plastic coming out of the hot end creates your model. Here a new print is starting. This is going to be a print of a simple box, and right now the hot end is moving around and putting down a thin line that is just priming the nozzle. So this outer border will actually be around our printout in just a moment. And what we're going to have here is just a simple little box. We're using just a box so that we can see whenever a line has to go left and right or forward and back, so X-axis versus Y-axis, we can watch specifically the motors that are responsible. So whether you noticed it now while it was priming or as we're starting the print, you can see that whenever the head has to move left and right, only the red X-axis pieces are moving, and whenever it needs to go forward and back, only the green Y-axis pieces are moving. Now, whenever we get to the infill, it's actually a diagonal line. At that point, we'll notice that both green and red pieces are moving together. The X and Y motors frequently move together when 3D printing. The reason for this is whenever there's a line that is not strictly just the X-axis or strictly just the Y-axis, it takes a combination of both motors, sometimes at different speeds, to make things like a curved line or a diagonal line or pretty much any shape that you could need other than just a straight line in X or Y. Here we've jumped ahead so the first layer is completely filled in, and again it's going to repeat the border of the box and then move on to the infill. Now this time, you do already know that the X and Y motors will work in unison, but did you know that the Z-axis motor is also working alongside the X and Y motors? Typically, we think of the Z motor as simply moving the hot end or the print head up between each layer, but it also is ensuring that each layer is laid down basically level to the print bed. The print bed may be slanted to the left or the right or the front or the back, so the hot end may be higher or lower whenever it's at the front or at the back of the print bed. So you can watch that the actual coupler here that holds the threaded rod is twisting clockwise and counterclockwise while a single layer is printing. So this is simply, again, just correcting to keep the new layers equal to the slant of the print bed. 3D printing is really just pushing plastic out in the pattern of X, Y, and Z movements. That's really all there is to it. And you can see it here because of the red, green, and blue representing X, Y, and Z. Thank you for watching.